GLM 5.2 just beat GPT 5.5 on 2 major coding benchmarks and costs about 1/6 the price. That's the number that stopped me cold when I looked at the data, and it's verified across multiple independent sources. GPU AI dropped this model with some pretty bold claims, and developers are already making real hosting and deployment decisions based on them. So I went through GLM 5.2's 5 boldest claims to see which ones actually hold up, using verified sources and zero vendor spin. Now, 2 of those claims don't just hold up, they actually exceed what was advertised, but one claim is so far off, it could wreck your entire deployment plan before you even get started. Alright, so who's actually deciding whether to adopt GLM 5.2 right now? Developers and small teams who want a fast, open-weight coding model without paying GPT 5.5 prices. If the claims hold, you get production-level quality at a fraction of the cost. If they don't, you're spinning up multi-GPU infrastructure for a model that can't do what the launch blog said. Claim 1, GLM 5.2 matches GPT-4 on reasoning and coding. And if this is hype, you're paying for a model that loses to tools your team already has. Worse, you've already swapped out your pipeline, burned the migration time, and now you're finding out it underperforms on the actual coding tasks you care about, and rebuilding from scratch. Okay, so I was expecting a close race against GPT-4, maybe a slight edge, but what I actually found is that GLM 5.2 was tested against GPT 5.5, which is a tougher opponent, and it still won. SWE Bench Pro 62.1 versus 58.6. Frontier SWE 74.4 versus 72.6. Both clear wins, and the price gap is sitting at roughly 1/6 of GPT 5.5. This claim delivers, and honestly, it over-delivers. I was expecting a modest win over GPT-4, and what came back was a win over GPT 5.5 at a fraction of the cost. So GLM 5.2 takes this one because it's the strongest open-weight coding model on both benchmarks right now. That's one of 1 claims holding up so far. Claim 2, 1M token context without degradation, and if you're running a legal document review or a massive codebase through this thing and quality falls off a cliff at 500k tokens, you've wasted the whole run. You get garbage output on the back half, and you probably don't even know it until something breaks downstream. So the 1M token window is real, multiple sources confirm it, and the index share architecture actually cuts flops by 2.9x at that scale, which is pretty cool. But the no degradation part of the claim has 0 formal benchmarks behind it. No official quality testing at full context, and I looked everywhere and found nothing. This one's partially true. I was expecting either solid proof or a clear bust, and what I got was something in between. The window exists and it's efficient, but the quality claim at the far end is just unverified right now. So we're at 1 full claim holding up, 1 partial, 2 tested total. Claim 3, GLM 5.2 runs efficiently on consumer GPUs with 24GB VRAM, and this is the claim that matters most to indie developers and small teams. If it's wrong, you're not just disappointed, you're looking at 4 A100s to run this thing, which is a completely different cost conversation and a completely different infrastructure decision. Okay, so this one hurt a little. I looked at the hardware requirements, and the minimum memory footprint at 2-bit quantization is 245 GB. So a single 24GB GPU can't even load the model. And if you try offloading with 24GB GPU plus 256 GB of RAM, you get single-digit tokens per second, which is basically unusable for any interactive work. This claim falls short and hard. I was expecting maybe a squeeze, maybe some trade-offs, and what I found is that it's not even possible on a single 24GB card because you need 4 aux A100 80GB at minimum for production. So we're at 1 claim fully delivering, 1 partial, 1 clear miss, 3 tested total. Claim 4, GLM 5.2 is a multilingual rival to Claude 3 and GPT-4 across 50+ languages. And if you're building a product for non-English markets and this claim is vapor, you've shipped something that quietly fails your users in French, Japanese, or Portuguese, and you probably won't catch it until a customer does. So I went looking for multilingual benchmarks, any of them, and found absolutely nothing. No published figures, no independent tests, no comparisons to GPT-4 or Claude 3, and the claim says 50+ languages with minimal trade-offs, but there's not a single data point to back that up. Honestly, I was expecting at least something, even a partial data point, and what I got was total silence. So this claim is unverified, which I'm counting as a second partial. Right now, we're at 1 claim, fully holding up, 2 partials, 1 miss, 4 tested total. Claim 5, inference latency is 40 to 60% faster than proprietary models. And if this is wrong and the model is actually slow, every agentic loop you're running gets more expensive and more painful, because a slow time to first token on a coding task means your developer is just sitting there waiting, and that adds up fast across a whole team. What surprised me here is how much the claim undersells the actual numbers. Time to first token, 1.36 seconds for GLM 5.2 versus 23.82 seconds for GPT 5.5 and 30.79 seconds for Claude Opus 4.8, which is 17x faster, not 40 to 60%. Output speed hits 106 tokens per second against 65 for GPT 5.5, and coding task completion was 49% faster, which is right in the claimed range. This claim delivers, and then some. I was expecting a modest speed edge, and the TTFT gap came back at 17x, not 40 to 60%. So GLM 5.2 takes this one by a wide margin. That wraps our 5 tests, 2 claims fully delivering, 2 partials, 1 clear miss. So here's where GLM 5.2 genuinely shines. It's the strongest open-weight coding model on SWE Bench Pro and Frontier SWE. Beating GPT 5.5 on both, the 1M token context window is real and flop efficient thanks to index share. Inference speed is in a completely different league at 1.36 second TTFT and 106 tokens per second, and it's MIT licensed at roughly 1/6 the cost of GPT 5.5. Now, where GLM 5.2 falls short, no softening. You cannot run it on a single 24GB GPU because it needs 245 GB of memory minimum, and offloading gets you single-digit tokens per second. The multilingual claim has 0 benchmarks behind it, so don't trust it for non-English production work, and quality at the full 1M token context is still unverified. Honestly, I was expecting more mixed results, and what I got is a model that's a genuine coding powerhouse, but a local deployment nightmare. So here's the decision rule. Worth it if you need a fast, open-weight coding model with a 1M context window and you can afford multi-GPU hosting. Skip it if you need local deployment on a single card or rely on verified multilingual support. 1/6 the cost, but only if you can actually run it.